First of all, welcome. My name is Ben Burt. I'm Director of Sales Engineering for APAC and EMEA here at Virsec. With us, we have Matthew Morris, Sales Engineer, and Danny Kim, Principal Architect here at Virsec as well. What we're going to do today is talk about how Virsec reduces patch panic. So Virsec stops the exploits on your server workloads, thus reducing security response. So Virsec's platform maps what your software is supposed to do in real time and instantly stops bad actors. So by doing this, we're taking the guesswork out of server protection, stopping you having to react to alerts and do incident response, and therefore start preventing breaches in the first place, negating the need for that detection response. How Virsec works is we secure your server workloads from the inside. And by doing that, we can see both known and unknown vulnerabilities. And again, giving back that patch panic, therefore giving you back your weekends and holidays and not having to jump every time there's a new vulnerability and things released into the wild, gives you a bit of peace of mind that your applications are doing what they're supposed to be doing. So as part of that, we now have Matthew Morris is going to give us a demo on how Virsec stops the latest Atlassian Confluence CVE. And I'll jump to Matthew now. Thanks, Matt.
Thanks, Ben. Thanks everyone for joining today. So today we are specifically talking about this CVE here. So this was a 0-day vulnerability in the on-premise version of Confluence. So we can see here that Atlassian did basically classify this one as critical, and of course ask their customers to patch it urgently. So as we could imagine, that would have caused a fair bit of patch panic within organizations. So really, what we want to show today is how that panic could have been avoided through these systems being protected by Virsec. So just to begin with, I'm just going to go through the attack kill chain for this specific vulnerability. So this vulnerability started with the attackers checking for vulnerable Confluence systems, and once that vulnerable servers were detected, that's when the adversary is actually going to exploit the CVE, and this one was a command injection attack. So then once they've exploited the CVE, the adversary can then execute commands on the system. They can extract information, but most importantly, what they're going to do is download a backdoor onto that system, and that's going to establish a reverse channel to the attacker's machine. And once they've reached this point, really it's fair game. It's up to the attacker's imagination. Generally, what they're going to do next, though, is send malware to the system, and this is when the malicious activity really starts. Once they've done that, the attacker could use that foothold to elevate privileges. They could run ransomware on that system, or they could even just use it as an avenue to move laterally within the victim network. So the Virsec system protects at step 3 of this kill chain. So that's when the actual exploit, the CVE is being exploited. But because we're a multi-layered protection solution, we also protect at other layers of this kill chain. So we can detect and prevent the actual attempt to execute commands into the system, but also when the malware is attempted to be deployed onto the vulnerable server. So now just jumping into a demo just to take you through this specific vulnerability. So we have a demo Confluence system here. It's running version 7.13.5, which is a vulnerable version of Confluence. So this system here is running at address 1047.698. And if I go across to the Virsec central management interface, what I can see here is that this system is currently protected by Virsec. So to begin with, we're going to be intentionally running in detect mode on this system. We just want to see the attack actually unfold successfully. So to run through this attack, I'm basically going to use a pre-built attack script. here, basically going to pass it the IP address of the Confluence system. So that attack script, it's going to check, make sure that that system is vulnerable to the CVE. Once it's confirmed that it is vulnerable, we're going to basically create that reverse channel onto the system. And now it appears that that's been successful. So I can confirm that that's run successfully. If I run ifconfig, I can see that, yes, I have in fact gained access onto that Confluence server. Also, if I run, who am I can see that I've gained access as the Confluence user, which is a privileged account. So now I've got access to this system, and I can really start my malicious activity and do what I want onto this system. So just flicking back to the management interface, what I'll see here is that we have a couple of incidents that have been created. So what we can see here, so we've basically identified a command injection incident. And what you'll see here is all of the information related to what we've detected, where the attack originated, but really most importantly, what we're seeing here is, here's the raw command that was run. I can see here where I've run the ifconfig command. And similarly, in the other incident, I can see that I've run the who am I command as well. So what I'm going to do now is just flick into protect mode and run through that attack again. So, very simple process to change into protect mode. And once that's done, that's an immediate process. And this system is now actively in protection mode. So I'm just going to jump back onto my system. I'm going to exit out of that shell and just going to run that command, that attack script again. So running that script, so the server is of course still vulnerable to that CVE. So again, we're going to attempt to create that reverse channel onto the system. So it looks like we may have been successful here. So let's see, have a look if I'm on the system, and look, haven't been able to execute that command. Similarly, if I go who am I, again, I haven't been able to actually inject commands into that system. So going back, what we'll see is we have a couple of new incidents that have been created. So this one, it'll look similar to before. I can see all of the information. I can see the attempt to run the ifconfig command. But of course, the biggest difference now, because we're in inline protection mode, we've actually actively blocked that attempt. And same for this incident here, we can see the who am I command, which we have prevented from being executed. So really, what we're showing here is that, while the system is still vulnerable to the CVE, what we've really done is just, we've prevented the adversaries from actually exploiting, that vulnerability and injecting commands into the system. So, I guess what we really want you to get out of this is that, it is about reducing that panic. There is no need to have the panic associated with emergency patching. We want to be able to give customers, the confidence and the comfort that, their systems aren't going to be compromised, from the time that 0 day is released and when they get around to actually patching their systems. Thanks for that. So I'm just going to hand back to Ben now. He's just going to wrap up the session and launch into a bit of a Q&A. Thanks, Ben.
Thanks, Matt. Perfect. So again, we've shown you how Virsec can protect against these known and unknown vulnerabilities and protect the applications from the inside. Again, we're doing this without the need for signatures and hashes and a threat intelligence cloud. Specific use cases around this are things like air-gapped environments, which I think is pretty unique to our technology. I'll now pause for a moment, and the team here will help answer any questions that you have that are posted via Q&A. Of which I'm not seeing any questions. Okay. So we've got one question come through. I might get Danny to answer this. And no, Danny, so how does Virsec stop a vulnerability that was not known before?
That's a great question. So with VSP, what we really try to focus on are two main fundamentals of a great security product. So the first thing we do is we use a full stack approach, meaning we not only protect the host layer, but we also are looking at the memory layer as well as the web layer. Every server workload has these different layers deployed, and we think it's important in order to provide the best deterministic protection. We need visibility into all three. And so our product not only looks at one in isolation, but uses all three in context to really build a deterministic approach as to finding these deviations. I think the next thing that we do is we focus on fundamentals, right? We don't use a probabilistic model. We don't need to monitor your system for some time to sort of baseline the behavior. What we look at are just fundamentals of how every server workload is supposed to operate. If you look at down to the process level, the way that your Java application is running, the way that the memory looks, we use fundamental approaches in order to identify just common threads that all server workloads, irrespective of their form or function, follow. And so because of that, we use this approach in order to not only protect server workloads of one type, but across all different types of deployments.
Great answer. Thanks, Danny. So again, the point we want to make here is that we are working from the application in, where we live as part of the application, therefore we can see these attacks without prior knowledge. And doing that, we can reduce that patch panic, as we mentioned, and give you back that time to allow those applications to run as they're intended to, without worrying about these known and unknown threats. I'll pause again for another question if there's any. No other questions at this stage. Okay. What I'd like to do is thank Matt Morris and Danny Kim for their time and helping us answer these questions and giving the demo today. So again, reach out to us on LinkedIn or via virsec.com if you'd like to speak to us and get some maybe a deeper dive into this technology. We do demos and we can do proof of values and proof of concepts. Again, thank you very much for your time. I appreciate your time on a Monday morning, Melbourne time. Thank you all, and we'll see you again. Thanks.
Thank you. Bye.
Thank you.
Thank you.